All right, guys. Welcome back to, part two of this lesson, okay? It's going to be substitution and elimination method, and this is continuing off of the graphing method. Now, we went off in these terms when we left off. So it was consistent and independent was the adjective we use when we have intersecting lines, just one solution, okay? Dependent, consistent dependent means that there's infinitely many solutions. That means it's the same line, okay? And then inconsistent means parallel lines, no solutions at all. There's not going to be a point or an xy value that will satisfy both of those equations. I mean, don't get me wrong, there's still solutions for this line and for this line, okay, but just not together, okay? So substitution method, if you're one for writing down rules, then this would be the perfect time to do so. We're going to solve the equation for one of the variables, either x or y. We're going to substitute the resulting expression into the other equation to replace the variable, then solve it. And then we're going to substitute to solve for the other variables. Okay, we use the word substitute quite a bit in this one, don't we? Okay, so let's do an example. Let's put this to practice. I have two examples that we're going to do, and then we're going to describe it as consistent, independent, consistent, dependent, or inconsistent. Okay? So let's take a look at the first one. X minus 5. Oh, no. X minus y equals 5. I don't know where that came from. Okay, so there we go. Now, just like the name implied, we're going to solve for one of the variables. And you want to pick an equation that you feel like is going to be easy to work with to solve for something. Okay, I don't want to pick an equation that's going to take me 10 steps to solve for one of the variables. I think the first one's going to be it, right? So I'm going to take this guy, okay, and I'm going to solve for one of these values. It doesn't matter which one. I mean, I could add y to the other side and solve for x. Want to do that? Actually, I think that's different than how I did it on here. Okay, but once again, there's more ways of solving it than just my way. So you know what? We're going to do that. We're going to add y to both sides. So x is equal to y plus 5. Okay? So we solved for x. Now we're going to plug into the second equation. All right, that's what we're going to do next. So right here, we're going to plug it into here. So we're going to take this x out. Boom, it's gone. I'm going to put this in its place. So y plus 5 equals 2y. Plus 2y equals negative 4. I don't know why I'm messing that up right now. End of the day, probably. Combine like terms. So I got 3y plus 5 equals negative 4. Okay. So 3y equals negative 9. We're going to take the 5 over and then divide both sides by 3. I get y to be negative 3. Okay. Now, here's the deal. I'm not done. Remember, the solution to this is a point. It's an xy point. It's where they intersect. So I have to take this guy and plug it back in. Okay. Now, some people ask, which equation do I plug it into, Mr. McCullough? It doesn't matter. I could plug it into this guy. Isn't that the same thing as this? I just rearranged it. I could plug it into this guy if I wanted to. Because remember, this y value works for both of them. So I'm going to pick this guy. This is the easiest. So now I'm going to sub y equals negative 3 into a previous equation to find x. Okay? So I'm going to pick this guy. So x is equal to y plus 5. X is equal to negative 3 plus 5. X is equal to 2. So my answer, now here's the deal. I'm going to erase these boxes in the circle. And the reason why I'm doing that, there we go, is because it's not really the answer. So my solution would be 2, negative 3. That is my answer. So answer, this is the point of intersection. that's the important thing. You need to know that, yeah, this point makes both of these guys true, but it's where two lines intersect. Know the geometry behind it, because when we talk about a system of three equations with three unknowns, the geometry makes solving it a lot more, I don't know, easier to understand. We'll get to that. Okay? Now, we could check our answers, right? Just like the previous one. If I plug 2 into here, minus a -3, which is plus, it does give me 5. 2 plus, that's a -6, will give me -4? Yes. So that actually works for both. Okay? Not too bad. Let's do another one. Okay. So we're going to do this by substitution method. So I got to solve for a variable, and I think this one's calling my name because if I take 2x over to the other side, y solved, right? And I can use that to plug it into this guy. So that's what I'm going to do. So this guy, I'm going to draw an arrow, and I'm going to say y equals -2x plus 7. All right. Now, what I've done before in the past, I've actually, the phone would ring at this time. I hope it's not important. Hello? Hey. Mm-hmm. Yeah. Mm-hmm. Yeah, that's fine. Okay, appreciate it. All right, thanks. See, you're just like in class, okay? I get phone calls and everything, so sorry about that. What I'll usually do is I'll number these just for my sake so it makes it easier. And if I'm making myself little notes in the problem, I'll say, okay, now I'm going to sub into equation 1. Like, I'll do stuff like that. Does that make sense? Okay. So here I go. So this is going to be 5x minus 3 times the quantity of -2x plus 7 equals 23. Okay. Remember, you don't want to plug this back into here. You're just going to get the same answer. It's not going to give you nothing. So for here, we get 5x plus 6x minus 21 equals 23. After I distribute these, right? I get 11x, adding those together, minus 21 equals 23. Okay. So 11x will equal 44. Divided by 11, I get x to be 4. Okay. Now I'm not done yet because I just found the x coordinate that both of these guys are a part of. I need to know what the output is. So I'm going to plug this. I'm going to plug back into, well, you have options. I mean, you could plug it into here. You could plug it into this guy because they're the same equation. You can plug it up here. I'm going to plug it into here. Why not, right? If I plug an x in, all I got to do is add 7. So y equals -2x plus 7. Y equals -2 times 4 plus 7. Okay, so that's -8 plus 7, which gives me -1. So my solution will be 4, -1. So this is the point of intersection. Okay, that's it. Not too bad. Now, both of these systems, we're going to describe them using the terms I just gave to you. They both be classified as consistent and independent. Okay, they don't rely upon each other, and they're their own individual identity. Really, they're their own individual graphs. Okay, so these would be both consistent and independent. Okay. All right, elimination method. So this will kind of wrap things up. We're going to multiply one or both of the equations by a number to result 2 equations that have opposite terms. Then we're going to add the equations, eliminating one of the variables, either an x or a y, and then solve the equation. And then we're going to substitute, or bringing that method back in, into the original equations and solve for what we have. Okay, so if you, once again, if you like to write steps down, which I highly recommend you do, here it is for you. Okay, we're going to go ahead and try these two examples out. And right up here. So we have 5x plus 3y equals negative 19. 8x plus 3y equals negative 25. Also, speaking about the geometry of this, I do have some videos on how substitution and elimination work geometry-wise. Yeah, well, we'll say that, but we'll get to that a little bit later. I'll probably post a video on it. It's pretty cool. I mean, a lot of times you probably think in math, all right, we're just manipulating a lot of things. Is this accurate? Is this really what's happening? And if we look at the visual side of things, it does work. So let's look at this guy. So the goal is we're going to eliminate a variable, and this is how we're going to do it. We're either going to add or subtract these two equations together, all right? And the goal is an x or a y is going to be gone. Now, currently as we stand, if I add these two together, nothing's being eliminated. If I subtract them, I think we do have something here, right? So here's what I typically tell people. I don't like to use subtraction that much, all right? I like to use addition just because it makes it easier to work with these numbers, okay? It's up to you. You could subtract these and get your answer. You just have to be careful. Or what I'm going to do just to show you, I'm going to multiply this by -1, okay? So I'm going to rewrite this. Like so. Now I'm going to add these two equations because when I do that, these y's cancel. And I get an equation with one variable. 5 plus a -8 is negative 3x. 3y minus a 3y is gone. Negative 19 plus 25 gives me 6. See how that works? This is my equation I'm going to solve for now. Divide both sides by -3, and I get -2. Okay? Now, could I have eliminated the x's? Yes. Could I have eliminated, them by multiplying this by a number and this by a number, then adding them? Absolutely. Okay? Now, we're going to sub back into, well, what equation? Doesn't matter. This one has smaller numbers, so I'm going to sub it back into equation 1. So let me just put a 1 and a 2 here so we know what I'm referencing to. So this guy is going to be 5x plus 3y equals -19. So 5 times -2 plus 3y equals -19. So -10, that becomes. Okay. I'm going to add 10 over to the other side. And then divide by 3. I get -3 for that. So my solution, both of these lines intersect at -2, -3. Okay. Does that make sense? Now going back to what I did originally, if I didn't multiply by the -1, let's just say I subtracted them right here, I'm going to get to this answer. That's no problem. But when you subtract, you got to remember that that's a negative sign here. -19 minus a -25 gives you a +6. So if you don't want to mess with the negatives, you can multiply by the -1 first and then add them. Okay? Some people say that's extra work. Honestly, I'm okay with either way. I'm just trying to show you. Okay? All right. Let's try another. Look at the next one. We have 3a plus 5b equals -27. 4a plus 10b equals -46. Okay. Now, looking at these ones, okay, I want to eliminate one of these. Now, it doesn't matter which one you do. Here's what's speaking to me. If I multiply this by a -2, doesn't this become a -10? And if I add it to this guy, I get 0, right? That's what I'm going to do. Okay. I could have done something different, and we'll talk about that afterwards. I'm going to multiply this by -2. So I get -6a minus 10b equals 54. And then this stays the same. I didn't change this guy at all. Okay? Let me just erase the arrows. Sorry about that. I'm just showing you where I was going. Now I'm going to add these together. So -6 plus 4a is -2a. Add these guys, are opposites, I get 0. 54 and -46, what, 8? I believe, right? 4, yeah, 8. Now solve what's left. Divide both sides by a -2, I get -4 for a. Okay. Now, I'm going to substitute these somewhere. It doesn't matter where, to be honest with you. Is there an easier one to work with? I don't think so. We'll just pick the first guy. So I'm going to sub it into this. So 3a plus 5b equals -27. So 3 times -4 plus 5b equals -27. So this becomes -12, right? Add 12 to the other side, I get 5b. Okay, it's equal to what? Be what, -15? Divide by 5, get -3. Put these together, my solution would be -4, -3. Okay. Now, once again, that's assuming that the first spot's A and the second spot's B. Okay. Usually, when they write equations like this, whatever the first letter is, that's your independent or that's your input. Your second letter is your output. Okay. So if it's not X and Y, it's still kind of thinking that it's X and Y. Okay. That's elimination. Now, let me give you a quick for instance. I always like to add extra things to these videos. Why not? Boop. Let's get rid of that. This is all gone. Goodbye. So long. Farewell. Instead of B's, let me get rid of the A's. Here's how I'm going to do that. If I multiply the top by a -4 and the bottom by 3, look what happens. The top is going to be what? -12a minus 20b would be equal to 8. Be a positive, what, 112? Am I right with that? Nope. No. No, I'm not. No, I'm not. My brain ain't working today. 4 and 7 is 28, so it's an 8. Okay. And then, why is my brain doing this? 2 is 108, sorry. Now down here is 12a plus 30b equals, what would that be? 120, 18, 138, -138 for that guy. What do you think? So far, so good? Okay. So notice something. When I add the A's together over here, they cancel. I get 10b. And over here I get what? -30? Something like that. Divide both sides by 10. I get b to be -3, which matches the original, right? It still gives us the same thing. Then I can plug it back into here if I want. So 3a, this would be what? -15 now, equals -27. So now add 15 to this guy, I get 12. -12, sorry. So a would be -4. So there we go. The same solution, nothing changed for that guy. How about that? So just to show you, it doesn't have to just be one equation. I could be manipulating both equations to eliminate a variable. So I wanted to make sure I showed you that. Okay? Last thing. And then we'll go through some naming stuff. Okay? I want to talk about the dependent one. Okay, remember this guy? Oh, this is what? Consistent dependent. When does this happen? Well, let me tell you. I'm going to make this one an easy one to work with. Okay? Make this very, very basic to work with. I have this system of equations, and I want to eliminate a variable using any sort of method here. I'm going to go for the x's. So I'm going to multiply this guy by a -2. Okay? So now look what happens. I get -2x minus 4y equals -6. And then this guy just comes right along for the fun. Okay? Now I'm going to add them. 0, 0, 0. Does 0 equal 0? Yes. What happened? You know, when that occurs, something went bump. What went bump? Well, look back at the original equations. These are the same thing. All I did is I took this top equation, multiplied it by 2. That's all it was. Nothing changed. Okay, look what happens. I'm going to solve this for y. Okay, so I brought the x over. I'm going to divide everything by 2. Here's my equation, right? I'm going to do the same thing down here. So I get 4y equals -2x plus 6. Divide everything by 4. I get -1/2x plus 3 over 2. I reduced the fraction, 6 over 4. See how it's the same thing? So once again, we could come up with a system where both equations are identical. We just don't see it because we multiplied it by some factor. And when that happens, we have these same lines. So no matter what values I plug in for this guy, it's always going to work for this guy because it's the same thing. That's why we have a consistent dependent system, one line. Okay, so a lot of people wonder, why does that happen? That's why. Okay. Now, what happens when we do this and we get this instead? Let's say this came out to be like, oh, I don't know. Let's say we got this. I don't have, this example isn't going to work. But let's say after adding two equations together, we get 4 equals 0, which isn't true. Okay, that is an inconsistent system. Okay, that is when we have two parallel lines here and it doesn't work out. There's not a solution that works. So when you use elimination method or substitution, you'll see that they're not going to equal each other out. Okay, does that make sense? So just some extra information, but it makes you think a little bit like, what happens? What can make these equations go bump? What can make these systems not work out? Okay, and it's good to think about those methods in that way. Okay. All right. So here's what I want you to do. I'm going to go ahead and go through these answers. So we have a system here. Okay, and what type of system would it be? You can always pause the screen and write your answer down. Okay. The answer would be what? A, consistent and independent, because there's one solution. Okay, let's keep going. Next one. I think we just did this one. Looks similar to it. So looking at it, this would be a B. This would be a consistent dependent system. Okay, dependent because both of these equations are the same one. Okay. Next one would be what? Inconsistent. There's no solution. That's the adjective we use for that. Okay. This one, we graphed everything. Now look at what happened here. Wow. There's a lot going on in this picture. Okay. This is like our grand finale here. So 2 of these functions is a system that works and 2 of them isn't. think the answer is going to be A. F and G. Where is that? F and G. Actually, no. That's not it. I think it's going to be C, huh? F and H, so here's F, here's H, are consistent and independent. They intersect at one point, right? Yeah, so it's going to be this guy. But I think G and H do it as well, huh? Am I missing something? Oh no! Oh bother. I did. I'm so sorry. Which is, it's not true. This is what happens when you don't read the full statement. See? Teachers do it too. Not true. That's A. Okay? They are not consistent and independent. These are parallel lines. They're inconsistent. That one's not true. The rest are true. After saying that, I'm like, wait a minute. This is true. And then when I was thinking in my head, I'm like, wait a minute. B and D are true as well. So yeah, A doesn't work. Sorry about that. Okay? All right, that's it. Okay, that's all I have for you. The video is long enough for right now. If you have any questions, please let me know. Reach out to me. But this is what we're going to practice for like the next 2 days. Okay, so make sure you understand how to work each one of these methods. Until the next video, have a good day, guys. Enjoy it.